My name is Mario Mata, and this is my experiment empirical formula of magnesium oxide. The purpose of this experiment is to find the empirical formula of magnesium oxide. My question is, what is the empirical formula of magnesium oxide? As you can see, this is my experimental design. I have my ring stand holding my clay triangle, holding the crucible, which is being burned by the Bunsen burner. These are the materials I used in my experiment: Bunsen burner, ring stand, clay triangle, scale, magnesium ribbon, and tongs. For my procedure, first I find the mass of crucible inlet, then find the mass of magnesium. Coil a magnesium ribbon and place it in the crucible. Let it start burning with the lid off. Then, when the magnesium ribbon lights up, immediately cover the crucible. After it's burned, let it cool down. Measure the mass of crucible plus lid plus magnesium plus oxygen. Using previous mass measurements, find oxygen's mass. Find the empirical formula of magnesium oxide and the percentage. These are some pictures I put in my procedure. First, we burn the crucible. Then, when we see the magnesium starting to light up, we cover it immediately with the lid. And then you can see how it was when it's burned. And in the last one, you can see how we're letting it cool down. Some safety equipment we used in this experiment were goggles, apron, and heat-resistant gloves. For my data, I measured the mass of magnesium, which was 0.67 grams, the mass of crucible and lid, which was 40.5 grams, and the mass of everything together, which included crucible, lid, magnesium, and oxygen, which was 41.5 grams. Then I measured the mass of oxygen, which was 0.07 grams. For my calculations, I had to find the empirical formula of magnesium oxide. To do so, first I had to find the mass of oxygen. So I used the mass of crucible, lid, magnesium, and oxygen, 41.5 grams, minus the mass of crucible, lid, which was 40.5 grams, minus the mass of magnesium, 0.67 grams, to find the mass of oxygen, 0.07 grams. Then I had to find the moles of both elements. So for magnesium, I divided 0.67 grams divided by 24 grams, which is equal to 0.0043 moles. And for oxygen, I divided 0.07 grams divided by 16 grams equals 0.028 moles. Then I had to divide it by the smallest moles, which in this case was magnesium. So I divided 0.0043 moles divided by 0.043 moles, which is equal to 1. And for oxygen, I divided 0.028 moles divided by 0.0043 moles, which is equal to 6.6 moles, which I rounded to 7 moles. So I got MgO7. For my calculations in percentage error, I used magnesium, which is equal to 180 grams, and oxygen, which is equal to 40 grams. And I did 180 minus 40 in absolute value divided by 40 times 100, which was equal to 350%. For my analysis and conclusion, my group and I found that our percentage error was a bit high. The reason was that our crucible was a little dirty from the bottom, and this affected our results. The empirical formula should have been MgO, but instead we got Mg7O. For my application and extension, we learned that knowing how to find the empirical formula can work for many things, like finding out an unknown compound that could make new discoveries. It is important to know the empirical formula of compounds so that scientists can know how dangerous a compound is to us.